identify the properties of cathode ray. Okay, properties of the cathode ray. Okay, so first one, you can see it is moving in a straight line. So move in straight line. Okay, move in straight line. Number two, you can see deflected by, here is what? Magnet. Okay, deflected by magnetic field. And then this one, number three, deflected by electric field. That means the cathode ray can be deflected by electric field and also magnetic field. And according to the way it is deflecting over here, okay, you see over here, positive, positive, negative. Why it deflect upward? Because the cathode ray is what? Negative charge. Okay, question is direct, actually simple. Those who already studied, they can answer. Those who already skip this in school, gone. Yeah, so simple. And then state one similarity and one difference between the cathode ray and light ray. So cathode ray, okay, and also light, both carry what? Carry energy. Carry energy. Simple, both carry energy. Have wavelength, no problem, no need. We remember the easiest one. Carry energy. Cathode ray carry energy. The kinetic energy is the one that will be converted to light. Light also what? Carry energy. So this is one of the similarity. But the cathode ray, their speed is less than speed of light 3 times by 10 to the power of 8 meters per second. So light ray move at speed 3 times by 10 to the power of 8 meters per second in vacuum. But the speed of cathode ray is what? Slower or less than C 3 times by 10 to the power of 8 meters per second. Yeah, must be less or slower. And then the light ray do not have charge, but cathode ray is a negative charge. Okay, cathode ray is negative charge. Okay, so simple. Okay, then we go for the question number B. Diagram 5.4 shows the main components of the cathode ray oscilloscope. Explain how the cathode ray are produced in the cathode ray oscilloscope. Very simple. You need to tell the voltage that you're connecting, about 6 volt, low voltage to the filament. Okay, and when it's become hot, what happened? The cathode will be heated, electrons emitted, control grid, control the number of electrons that passing through the tube, and then anode focusing the electron into narrow beam. Yeah, that's all actually. Okay, you see the answer? Current passes through filament. Okay, current passes through filament. Filament become hot. Cathode heated. Electrons emitted. Okay, you want to write thermionic emission also can. Okay, high potential difference between the anode and cathode accelerate the electron towards the electron. Now, accelerate the electron. Okay. So that means you need to know the flow, the story. Okay, then we go for the question number 2. Explain how the bright spot P is formed on the screen. State the transformation of energy when, okay, which occurs in the cathode rays at spot P. Okay, explain how. Okay, I told already last week. Okay, please memorize this. Okay, I think 3 times I already asked this. Yeah, you must memorize. Okay, so kinetic energy, not charge, change to light energy. Heat, no need. Okay, but before that, please add when fast moving electron hit the screen. Okay, hit the screen. So this one they give a mark, and then second mark for the kinetic energy is converted to light energy. Okay, kinetic energy converted to light energy. Okay, you didn't test this kind of question in physics, so we must get ready. Okay, then here. Okay, I think I will. This sort of comparison. I think you can answer. Compare. Yeah. And also here I will give you the function, everything. Okay, so I will discuss this question only. Question C. Okay. Hey, now what time? 9:23. Now only joining the class. I think just wake up. Okay. Using the suitable concept, explain the modification to the cathode ray oscilloscope that needed so that it can, number one, determine the distance of an aeroplane from an airport. So this one related to chapter wave and electronic. Okay, waves and electronic. Okay, so we know, right? If you want to calculate the distance of the aeroplane from the radar, we have to use one type of wave, we call it as a microwave. So the microwave will be sent towards the plane, and then after that there will be reflection. The reflector sound will be detected, and then the time will be calculated using the trace that form on the screen of the CRO. After that, distance we can find using formula Vt over 2. You also can use this formula, but you have to define D is what, V is what, T is to what. Yeah. Okay. So here, normally for explaining, they will give you maximum 4 marks. Yeah. Okay. Microwave emitter. Okay. So highlight this. First, microwave emitter. Okay, enough. I mean towards the aeroplane. The wave reflected. I mean one of the phenomenon of waves occur because you are telling the correct terms over here. Okay, the microwave reflected and then detected by detector. I mean the echo, or the reflector sound detected by the detector. Okay, time interval between the transmission and reception. Delta T equals to what? X times with A, where X is what? X is the, okay, you see over here. X is the distance between the two peaks, correct? Distance between two peaks. And then what is the value for 1 division or 1 centimeter? That's the one that given over here. Okay. The distance between the peaks P and Q on the microwave, of the microwave measured x axiom. This is the distance between the two peaks. And then the time base is set to a millisecond per division. So if you want to find the time interval, take the distance between the two peaks, okay, times with the setting on the time base, you will get the time from the moment you send and then the reflector sound detector. Okay, and then the distance of the aeroplane from the airport. Okay, you don't want this, you can write like this. Distance, you want to write D also can. Okay, V T over 2. Correct? Formula. They will give you marks for the formula. And then the V. What is the speed of the microwave? Not only the microwave, all the electromagnetic waves. The speed is what? 3 times by 10 to the power of 8 meter per second. So here, 3 times by 10 to the power of 8. And then the T, you take this. X. Okay, AX divide with 2. Okay, so here missing one. You stop over here enough. You stop over here. Okay, finish. The next one is answers already given. I know if you copy everything one by one, it will take time. Yeah. So now, next one is determine whether an aeroplane is moving closer or further from the airport. So after 5 minutes, repeat the above steps. That means you're going to send the microwave again. Yeah. Measure L1. L1 is what? The distance. If the L1 exits, it means when you find the distance, right? Distance, yeah. When the distance is what? Further means the object is far away. It means moving away. Okay. So very simple. After 5 minutes, you repeat. Okay. Send the microwave again. If the distance getting further means the aeroplane is not moving away. If the distance getting shorter, that means the aeroplane is not moving towards. Okay. So 3, no one. Leave it. 6, 5. I will give you the answer. You check. Okay. This one comparison, no problem. Okay. Now we are going to continue with semiconductor diodes. Any questions? Huh? If no questions, then we can continue with semiconductor diodes. Okay, just want to refresh. Okay, semiconductor diodes. Okay, what is it mean by semiconductors? Semiconductors means it's a group of materials which can conduct electricity better than insulator, but not as conductor. So you need to memorize. Yeah. Okay, then or you also can write conductivity of electricity is between conductor and also insulator. Okay, examples, if they ask you, give one examples of semiconductor. Remember the silicon, the basic. Okay, silicon or germanium. These are the two famous. Selenium, not famous. Silicon or germanium. So we know already the silicon consists of 14 electrons at the outermost shell. So if you look at the third shell, got 4 electrons. To form octet structure, it needs to share another 4 more electrons with the nearby silicons to form the octet structure. And the type of bond is a covalent bond. Yeah. So this electron all is in the covalent bond. So if you want to release the electron, it cannot. Yeah. But when it release the electron, when the electron escape, move. So here what happened? It produces a hole. But how many electrons that it can release? Limited, because most of the electrons are in the covalent bond to reform the octet structure. So when the electron escape, so here it produces what? Hole, where the hole will become the positive charge carrier. So how many electrons that it can be donate over here or it can release? Limited. Okay, so the number of electrons that it can donate or release is limited. So that's why the conductivity of the semiconductor also will be limited. Okay, so if we want to increase the conductivity of the semiconductors, we need to carry on a process. Yeah, we call it as a doping. I go a bit fast here because last week I finished. So doping means what? Doping is a process of adding small amount of impurities into the pure semiconductor. Okay, process of adding small amount of impurities into semiconductors. Now, so the crystalline lattice, no need. Okay, process of adding small amount of impurities into semiconductors. Okay, then what? Okay, wait. Okay, so why we need to carry on process of doping? To increase the conductivity of the semiconductor. Okay, to increase the conductivity of semiconductor. Okay, now we continue. Types of semiconductors. So if you add pentavalent atoms into the pure semiconductors, pentavalent atoms, I give you short form, upper APA short form. Yeah, so that you can differentiate with the trivalent atoms. A for antimony, phosphorus, arsenic. Okay, when you add into the, I mean adding in a small amount, yeah. So these pentavalent atoms also we can call it as a dopants because you're using these to carry on the process, we call it as a doping. So when you add, for example, let's say if you add phosphorus, okay, phosphorus we know already is consist of 5 electrons. So 1, 2, 3, 4. Then you got a 1 more electron, the 5th electron. This is an extra electron. So this extra electron will be donated. So maybe here also got electron. It will be donated. Yeah. So this extra electron will be the majority charge carrier. Okay, it will be the majority charge carrier. And then after electron finish, what happened? The electron over here escape. When escape over here, it produces what? Hole. So the hole will be minority charge carrier. Majority is electron. Okay, so this electron is a negative charge. When you add the pentavalent atoms into the pure semiconductor, it will produce extra electron. This extra electron is a negative charge. So negative charge, so negative. So this type of semiconductor, we call it as N-type semiconductor. Okay, N-type semiconductor. So these pentavalent atoms, yeah, these pentavalent atoms, what happened? The 5th electron, right? The 5th electron is being what? Donated. So we call it as what? Donor atom. Okay, we call it as donor atom because it's donating the extra free electrons. Okay, now we continue with the next one. If let's say if you use electron is a majority charge carrier, holes a minority charge carrier. Okay, now if you add trivalent atoms, yeah, trivalent atoms into the pure semiconductor, examples, remember the big, or you can write bagi because we got aluminum, right? Okay, aluminum, I think all of you know. Yeah, so big for what? Boron, indium, gallium. So these are the examples of trivalent atoms. Just add a small amount only into the pure semiconductor. Diagram you need to know. They won't ask you to draw, but they can ask using diagram. Yeah. So when you add boron, so 1, 2, 3. So all the electrons finish. Because the boron consists of 3 electron valence at the outermost shell. So now there's a lack of 1 electron. So when there's lack of 1 electron, it is what? Positive charge. What is positive charge? It's a hole. It is a hole. So the hole will be the positive charge carrier. So here we got 1 hole. Maybe other places what? Got hole. Okay. So this hole will become the majority charge carrier. Okay, will become majority charge carrier. And then the minority will be holes. Right, so minority will be electrons. Yeah. So this hole is a positive charge carrier. Okay, it is a positive charge carrier. So this type of semiconductor, we call it as P-type semiconductor. Okay, we call it as P-type semiconductor. Okay, so the holes become the majority charge carrier. We know the majority enough already. Yeah, the 1 more will be minority. And then the electrons will be the minority charge carrier. Okay, so for P-type, it produces electrons. So later you will see I will use this symbol to represent electron. Okay, and then this is a N-type semiconductor. Right? For the P-type semiconductor, I will use what? Holes. Okay, this one is what? Holes, and this is a P-type, and this is what? N-type. Okay, so how a diode is formed? Okay, we can see the whiteboard. Okay. Okay, semiconductor diodes. semiconductor diodes. It is formed using P-type and also N-type semiconductor. P-type and also N-type semiconductor. So the place where the P-type and N-type attach together, this region we call it as junction. What junction? PN junction. Okay, PN junction. And then the terminals that are connected to the P-type, we call it as an anode. The terminal that is connected to the N-type, we call it as a cathode. Okay, P-type anode, N-type is cathode. And then symbol for diode is this. Anode, P-type. Okay, anode, you see the triangle over here, bigger, right? Bigger, then become narrow, yeah? So on the left hand side is anode. This terminal electrode is a anode. Over here it is cathode. Over here become cathode. Yeah? This is a symbol. Okay, now we are going to see how this diode is functioning. Yeah, how this diode is functioning. Those didn't type your name, please type your name in the chat box. Here, finish it. Okay. Here is a P-type, N-type. Yeah. Okay. When it is not being connected to anything, what happens is the holes. Okay, the holes from the P-type. Here is a P-type. Over here is an N-type. So what happens is the holes. The holes when it's not being connected, the holes will move from the left hand side to the right hand side. It will be drift. Drift comes to here. Hole. Okay, it will be drift come to the right hand side. Okay, so the holes will be drift across the junction, come to here. Okay, holes will drift, come to the right hand side. And then electrons will be drift from the right hand side, okay, go to the left hand side. It will be drift across this layer, come to here. Here is electron. So now, this region, at this region, it become neutral. Because the number of charges are balanced. So when the holes drift to the right hand side and the electrons drift to the left hand side, it produces a layer. We call it as depletion layer. Okay, it will produce a layer. We call it as depletion layer. Okay, in BM we say lapisan susutan. Yeah, in BM we say lapisan susutan. That means this layer, right? The size can increase or can decrease. Okay, the size can increase or can decrease. This, so the holes when being pulled across the junction, come to the right hand side. At the same time, electron drift to the right hand side. Okay. So at the middle over here, it produces the depletion layer, which is what it consists equal number of holes and also electron, and this region become neutral. Okay, and this layer, depletion layer, the size can increase or the size can be decreased. Okay, the size can increase or can be decreased. Okay, so this one main, but the electrons and holes cannot keep on flow because there's no energy, so that the electron can be move. Yeah, that's not enough energy to let the electrons to be drift across the depletion layer. Okay, but now how you're going to connect so that it can function. But two situations that you need to know, and you must know how to explain. So let's go through that. Here we got that title. Later I'll write the title. Okay, I give you the easiest one, then one more later. Yeah, I'll give you the reverse bias first. Okay, reverse bias. These are the holes there. Holes. Here will be electron. Okay, electron. Battery. Okay, but you can see there's a wide gap in between here for reason. Wait, Okay, here, let's say I connect to a bulb. Okay, connect to a bulb, and then here is a battery. You need to check the terminals of the battery, carefully. Okay, now This terminal we call it as anode, or it's what P-type. This terminal we call it as cathode, or it's an N-type, yeah? N-type semiconductor. And here is a negative terminal. Okay, negative terminal. Over here is a positive terminal. Negative, positive. Okay. Here positive, sure it will attract negative charges. So here electron, negative charges. So what happens is these electrons will be pulled towards the positive terminal battery, and then these holes will be pulled towards the negative terminal battery. Okay, it will be pulled. And here I told you already earlier, depletion layer, lapisan susutan. So what happens is, you can see over here, it's become wider, right? So here at this region, what happened? It produces wider or bigger depletion layer. Okay, wider depletion layer, or you can write depletion layer become wider. Yeah, depletion layer become wider. When the depletion layer become wider, resistance of the diode become very high. Okay, the resistance of the diode become very high. Ravindran didn't off your mic, Mr. Ravi. Okay, okay. Now, so the depletion layer become wider. So resistance of the diode become very high. So when very high, but does not lights up. Why? Because current cannot flow. Okay, because of the depletion layer become wider, resistance of the diode become very high. So in this case, what happened? The bulb does not lights up. So we say the diode is reverse bias. Okay, diode is reverse bias. Diode dipincang songsang. Yeah? Okay. So here I show using the P-type and also N-type semiconductor. P-type and also N-type semiconductor. Okay, but now let me show you the terminals of the diode using its symbol. Yeah? Okay, so here P-type and anode, then here cathode, right? Cathode. This is symbol of diode. So if this diode it is connected to battery, and here got bulb. This bulb, I see terminals, correct? Bulb. So this one symbol, but here I'm showing you the actual story. What is happening? Yeah? How is made using the P-type and also N-type semiconductors. Okay, so here the bulb does not light up because current cannot flow in this way. Current cannot flow in this way. But anyhow, can you see if we connect like this? Can you see the depletion layer become wider? Electrons is being pulled this side and that side and so on. Can you see? Cannot see, I know. But you need to write that also. Okay, when they give diagram of this, what you can see over here, that one can become the answer. Later I tell you how to write. Okay? Okay, so this is a anode. This is cathode. Okay, cathode connected to positive terminal. Yeah. So in this way, the diode won't allow the current to flow through it. So we say the diode is reverse biased. Okay, the diode is reverse biased. So you leave some spaces over here, I will tell you. Okay, small space so that you know how to write the explanation. Yeah, so that you can get marks in SPM. Okay. Now we come to the second case. Also got title. Okay. Now I can see the difference. And here we connect to dot. Terminals of battery. Same as here, right? Same. But now the changes is the terminals of the battery I'm going to reverse. See, I will reverse the terminals of the battery, or you want to fix the terminals of the battery, you want to reverse the diode also. Either one, yeah? But you cannot write both. We come to the question here. Yeah? When discuss, then you know. Okay, here and not on the left hand side, here is what? Cathode. Okay, listen first, later I give you time if you want to copy can later. Eh? Okay, so here negative terminal, over here is what? Positive terminal. So when the positive terminal of battery connected to the anode of diode, or we say what? P type. Okay, P type connected to positive. P type connected to positive terminal battery, or anode of diode connected to positive terminal battery. N-type connected to negative terminal battery, or cathode of diode connected to negative terminal of battery. Okay. So in this case, what happens is here positive. So the electrons, okay, the electrons over here will be pulled across the junction. It will pull across the junction, come to the positive terminal. Okay, the electrons will pull across the junction to come to the positive terminal. And then the holes, it will be pulled to the right, okay, come to the right, and then it will be pulled towards the negative terminal. So, when, okay, let's say two of you, okay, two of you, three of you, I'm in the middle, another two over here, and both of you pull towards each, okay, towards each of you, what happened? Let's say both of you pull, what happened? The distance become what? Further. Sorry, closer. The distance becomes closer. So here, when the electrons is being pulled to the left hand side, holes pulled to the right hand side, what happened to the depletion layer? Become what? Become narrow. Yeah? So the depletion layer becomes narrow. Okay, or thin. Also can, yeah? So narrow. Narrow, or depletion layer become narrow or thin. Or thin, yeah? Thin also can. So when the depletion layer become narrow, what happens? Resistance of the diode become very low. Okay? Resistance of the diode become very low. When the resistance is very low, what happens? Current will flow. Current flow, bulb light up. So now here bulb lights up, the diode allows the current to flow. So we say the diode is forward biased. Yeah? Diode is forward biased. Diode dipincang depan. Diode is forward biased. Okay. But in terms of symbol, now you see current flow. You see the arrow, you see arrow. In the same direction with this triangle, right? Same direction, right? So current can flow. This is the part where it will let the current to flow. So that means from these situations, we know already that the diode only allow the current to flow in one direction, one way. Cannot flow in the opposite direction, cannot. Only one way. Okay, the diode let the current to flow in one direction only. So now how you are going to explain this? Okay, we start over here. This one just reverse, reverse. I give you the points. So maybe in the exam they give you this. Oh, I forgot to label. Bar exam. Okay. Maybe in the exam they can give you this diagram, or maybe they can give you this diagram. Okay. But how you are going to explain? Okay, how you are going to explain? Explain, maybe here you cannot see what you can see in this diagram. But what you can see over here can be the answer over here. So both actually same. But here we are using what? Actual diagram. P type and also N type. But here we are using symbol. Okay. So please write points here. Okay. Anode, here also anode. Anode, here cathode, here also cathode. Okay. Anode, or you can write P type also can have anode or P type. Right? Anode of diode connected to, I use from positive. You don't write like this positive like this in the exam. Positive terminal of diode and positive terminal of battery. Okay. Anode of diode connected to positive. Anode of diode connected to positive terminal of battery. The next one is cathode. Cathode or N type. Cathode of diode connected to negative terminal of battery. Okay. 1, 2. Enough space. So the next one you write. This one just connection. You no need to tell about the movement of the electron. The one. Okay, no need to tell about the movement of the electron and so on. Holes. So what you need to tell is about the depletion layer, about the resistance, and then current flow or not, bulb lights up or not. Okay, if you tell all this, you can get marks. Okay, so point number 3. I mean this one connection here. So wait, anode of diode connected to P positive terminal of battery. Okay, cathode of diode connected to negative terminal of battery. Okay, the third one you write depletion layer of diode become narrow or thin. Depletion layer, please write over here. Depletion layer of diode become thin or narrow or thinner. Okay, depletion layer become narrow or thin of diode become high, resistor of diode high or increase. Okay, resistor of diode increase. The next one, current flow through diode. Please add current flow through diode.
So the resistance is low or high?
Okay, current.
Sir.
Yeah.
What should be the resistance of diode become lower?
Thank you. Yeah, resistance low, right? Okay. Resistance of the diode become low. Yes. Thank you. Resistance of the diode become low. Current flow through diode. Please add one more. Not enough space. Please add one more. Diode is forward biased. Please add this. It's a correct term there. Diode is forward biased. Diode is forward biased. Okay, diode is forward biased. Finish. I repeat, okay. For both diagram, the explanation same, but here you cannot see the depletion layer thin or thick. We cannot see, but you have to recall back this diagram. So, anode or P terminal of diode connected to positive terminal. P, positive P. Yeah, same. Okay, then anti-semiconductor or cathode diode connected to negative terminal of battery. Depletion area become thinner or narrow. Resistor diode become low. Current flow through diode. But, I forgot one more. Current flow through diode, right? And then follow over here. Please add one more. But light up. Please light. Although you can see over there, but light up here, right? But light up. Because the diode is forward biased. Okay, because the diode is forward biased. Okay, finish. Okay, come to this. Okay, follow the same techniques. You right? Tell you. Anode of diode connected to negative terminal of battery. If you know that, this one very easy. Anode of diode connected to negative terminal of battery. Okay, so here I write anode of diode connected to negative terminal of battery. One more, you write cathode of diode. Cathode of diode connected to positive terminal of battery. Okay, positive terminal of battery. Depletion layer become wider. Or thicker also can, depletion layer become wider. Resistance of diode become high or increase. Resistor diode become high or increase. Current not flow or does not flow. Current not flow. Bulb does not light up because, okay, the last one after this here, the last one, if you write, I think you cannot see. The last one you write, the diode is reverse bias. Bring it down and then write down there. The diode is reverse bias. Okay, the diode is reverse bias. Okay, the diode is reverse bias. Okay, finish. So you need to know how to explain this. So if you remember the diagram, very easy for you. Yeah. Okay. From here we know already. One of the function of the diode. What's the function of the diode? Allow the current to flow in one direction only. Yeah. So from this situation, you know already, diode only allow the current to flow in one direction only. Allow current to flow in one direction only. Okay, now the current to flow in one direction only. When I check currently, not many of you answering the Google form that I already give you. Very simple. Okay. Please reply. Please reply. When I check over here, only 174 of you already give the response. Maybe later they will answer. Currently, almost 65%. Only 65%. Sorry, 65% they say online. 35 face to face. Never mind. You answer first, yeah? Then I will tell you. Okay, finish. So from these two situations, you already one of the function of diode is what? Diode allows the current to flow in one direction. Take note, diode, function of diode allow current to flow in one direction only. Okay, allow current to flow in one direction only. Okay, diode allow the current to flow in one direction only. Okay, allow current to flow in one direction only. Okay. So now, because of the diode allow diode okay, diode allow the current to flow in one direction only. Okay, so we can use the diode to carry on a process. We call it as rectification. In VN, we say rectification. So we say rectification. So what is the mean by rectification? Rectification is a process of changing AC current or AC to DC. Process of changing AC to DC. But DC to AC cannot. Only AC to DC. Rectification is the process of changing AC to DC. And here we got two types of rectification. Okay, we got two types of rectification. First one, you write half wave rectification. Half wave rectification, and one more is full wave rectification.
Sir, the
Your camera is
is
not
too
focusing.
blur.
Sir,
Yeah.
your camera is not focusing.
Wait, Now okay.
Okay, sir, okay.
Okay, okay. Full wave, no need. Half wave rectification, full wave rectification. Okay. So half wave rectification is a full wave rectification. So that's why we also can say diode as a rectifier, because it is going to change AC to DC. Yeah, AC to DC. Okay. Now we are going to continue with first one. Okay. Okay. First, we check half wave rectification. Got explanation for this, yeah? Okay. Here I use diode Okay, here is a load. It's a load, or it can be anything. Any device that's going to use direct current, it is connected over here. And input over here, it is AC current. You can leave a small space on the left hand side, or the one also can, because later I'm going to make small changes over here. Okay, small changes. Okay, so input here is input, input. Here output. You want to see the current that flowing over here, how the input looks like. You can bring the CRO, just connect over here. You can see the waveform like this. And input. Then our actually this circle is complete. Complete. Here you want to fix a bulb also can. Okay, resistor or bulb. Okay. Then how about the output? How are you going to see the output? Very simple. You just connect to a CRO, cathode ray oscilloscope. It won't disturb the circuit. Just bring the two wires side, just go in between. It won't disturb the circuit. Yeah? So connect to a CRO, you can see the output that's flowing over here. Okay? So now let's check. Input is for AC. Input is AC. Okay, input is AC. So this is the one that given over here. Given over here. Then our output. Here is output. Here is what? Output. Sorry, here output. So we can see using the CRO. So how about the output? Here is the output. Okay. Wait, let me explain first, then only later you can copy here. Listen first. For the first, okay, this is what you call one cycle. From here to here is what? One cycle, one wave. Okay, one complete wave or one cycle. So for this one cycle or one complete wave, this one is what? Here. For the first, this one is say first half cycle. But I'm using short form. But this is what? This one for first half cycle. Sorry. First positive, positive half cycle. Here first negative half cycle. So one complete, this one is positive, this one negative. Then back to positive and so negative again. Okay. Now for the first positive half cycle, this one, here. Okay, let's say here terminal A, terminal B. Terminal A, let's say become positive, terminal B become negative. Wait. Wait, Okay, now for the first positive half cycle, A become positive, B become negative. So A positive, what happen? Current can flow, right? Current can flow. Okay, so that means here the first half cycle, no problem, can flow. That means first half cycle flow because that time the diode is forward biased. Okay, but we come to the negative half cycle. First negative half cycle, what happen? B become positive, A become negative. What happened? Current go in this way. Can or not? This way cannot. So what happened? The negative half cycle cannot flow. It cannot flow. Because the diode is reverse biased. Then come back to this again, what happened? Terminal will change again. A positive, B negative current flow through diode because of the diode is forward biased. So all the positive half cycle will flow. Okay, so here this is the first half cycle. First half cycle. For first positive half cycle. Okay, for the first positive half cycle. For the first positive half cycle, A become positive, terminal, B become negative terminal. A become positive terminal, B become negative terminal. Okay. Current flow through diode. Current flow through diode. Diode is forward biased. Okay, diode is forward biased. So for the first positive half cycle, okay, no need to draw the dot lines vertical. So for the first half cycle, it let the current to flow. So first one, no problem. It will pass through, you will get the trace, same trace. So it passed through. Oh wait, I need to erase. It passed through, clear. Okay, clear? Okay, come to the negative half cycle. Okay, come to the negative half cycle. Negative half cycle, what happened? Okay, let's check. For first negative half cycle, or you don't want to write first positive half cycle. You can write for the first half cycle, second half cycle. Also enough. Yeah. First half cycle, second half cycle. The rest will be repeating. Yeah. Okay. So now we come to for the first negative half cycle. So what happened? That's not A positive, B negative. But now B positive, A become negative. So A become negative terminal, B become positive terminal. Okay, A become negative terminal, B become positive terminal. So what happened now? Is the current can flow through diode? No. Current not flow. Simple, current not flow, or current cannot pass through the diode. Current not flow because of diode is reverse bias. So diode is reverse bias. So the negative half cycle you won't see. So it's just an horizontal line. Just a horizontal line. Flat. Okay. And then when the process repeating, when the terminal change again, A positive, B negative, what happen? So this one will flow again. How about this? Blocked. How about this? Flow again. So you get only half of the wave pass through the diode, right? Only half of the wave over here pass through diode. So we see it as what? Half wave rectification. So we say this as a half wave rectification. Okay. Now, one more. Excuse me. If you reverse the terminals of diode, or reverse the terminals of the CRO, either one. Okay, either one. Reverse the terminals of diode or reverse the CRO. Let's reverse. What you will see is very simple. Don't need to copy this. You will see all negative. Just goes below. That means the negative one only will pass through. If reverse the terminal. Okay, so don't copy this one. Okay, anyway, still what? This is a DC. This one is input is AC current, output is what? DC current. So only half of the wave that pass through the diode. So we say half wave rectification. Yeah, half wave rectification. Okay, so let's say over here I connect to a but sample here, no need to change, leave it. The current over here is what? Zero. Current zero. Then current increase the maximum, then decrease become zero, then no current flow. Increase become maximum, then decrease become zero, then no current flow. So whatever. But when the current not flow, like so, when current flow increase become what? Right, then dimmer. Then no current flow, right? No current flow, then current increase, become right there. Then become what? Dimmer. Okay, no current. Brighter, dimmer. Right? So, but anyway, we can't see the bulb off and also on because before the film cool down, the next current will start to flow. So that's why we cannot see bulb off and also on. Yeah. So here you want to see the output only the CRO. Yeah. You can use to display the waveform. That's why one of the functions of CRO is what? To measure potential difference. One more is to display the waveform. Yeah, to display the waveform. So here the current is not smooth. So what we have to do? We have to smooth the current. Make it smooth. How to smooth the current? We have to add capacitor. Yeah. So we need to add a capacitor here. Parallel to the load. Two lines with the same length. This is a capacitor. Okay. After capacitor added. Yeah. After capacitor added, how about the output? Okay, let's check. Also, you must know how to draw this. Before you add the capacitor, you will see what? Half wave rectification. Okay. Okay, wait, don't draw. Here is what? I use dot lines first there, dot lines. Okay, so actually this is the actual one. If you are using what? Only one diode. But now, after the capacitor added, capacitor, the function is it can charge and also recharge. When the current is flowing through diode, that time the capacitor will charge, will keep the charge. Keep the charges. When the current start to drop, that time the capacitor will release charge. When release charge, it won't let the current to back to what? Zero. So when release charges, current will flow. Okay, current can flow because the flow of charges and currents are in the opposite direction. So when the capacitor release charges, when the current start to drop, when release charges, what happen? It won't drop to zero. So it can maintain but slightly decrease until here. Then when the current start to flow again, that time capacitor will charge again, charge up. Then discharge again. So there will be charging and also discharging of the capacitor. So how to draw? You have to follow this. Okay. From the peak, you draw a line slightly slanting like this. Slanting, because I know many students will face problem in drawing. Actually, the trace will be like this. On the screen of the CRO, you will see the trace like this. How many of you know how to draw this? It looks easy, but when you draw, you'll face problem. So please follow the techniques I'm going to show over here. Okay. So here from the peak, draw this, and then here. Okay. Then we join it. Become a like waveform. Okay, so the dot lines, no need to erase, leave it. If you use the dot lines, that means half wave rectification, then you complete easy for you. Must practice to draw. Okay. So next one is from the peak until here. We need to label. Okay, we need to label capacitor discharge or release charge. Yeah? Capacitor okay, capacitor discharge. And then here, capacitor charging. So I don't label here, I choose here. I choose here. Then we put an arrow. Then write down capacitor charging or charge up. Okay, capacitor charge up. Okay, capacitor charging or charge up. Those didn't type your name in the chat box, please type. Okay, capacitor charging and also discharging. Yeah. Okay, so drawing these and also labeling like this, they can give you 3 marks. Okay, they will give you 3 marks. Draw and label. So this is what we call half wave rectification. Yeah, half wave rectification. Like I told you before, yeah, in the adapter of a laptop, input 240, output about 19 volt. Inside got transformer, AC become DC. So the main got transformer and also got diodes. Okay, also got diodes. So for that one, okay. Finish? Okay, let's continue. Over here. When I make a small changes, don't worry, don't make any changes. Leave. Just for your knowledge. Because sometimes you can create, just add over here. Okay, here is what is
Transformer.
transformer. Okay, it is a transformer where let's see the input voltage is 240. Let's say 240. So you are going to step down, become let's say 20 volt. So we have to use a step-down transformer. But still what? Still AC, right? AC. Input AC, output what? AC. Then the AC it is going to be changed to become DC. This is the output that you will get if you are using only one diode. But if you add capacitor, this is the output that you will get. Okay, so also it is a DC, but DC with a capacitor, this one DC without capacitor. So must know how to differentiate. Okay, I hope you got the idea. Okay, this is what is called half wave rectification. So now I want to continue with the full wave rectification. So looks like lack of time, but we try to cover. Okay. Finish here. Okay, let's say the exam you saw this. Don't copy this. Also, it is a half wave rectification. I mean the terminals reverse, that's all. Or maybe the diode reverse. Okay, or you will see the place like this. It's a bit difficult to draw. This one just reverse. Okay, just reverse. Only one direction. Okay, so this is a full wave, half wave rectification where only half of the wave that passing through diode. The negative one cannot pass through. But now, how you are going to let all to pass through? How? I mean, all pass through, then the current and the output must be in the same direction because we want direct current that flow in one direction only. So we are going to continue with the second one, B, full wave rectification. Okay, full wave rectification. We are going to finish this subtopic already now. Once finish a full wave rectification, then finish this subtopic. So next class we can start with the transistor. So transistor, a bit difficult. But when I teach my students in school, they can get idea. Very simple. Yeah? Okay. So now we go to the full wave rectification. You must know how to draw. Okay. On the left hand side and right hand side, please give some space.
Sir,
Yeah.
your camera is not focusing again.
Blur. Wait. Yes, over here, raining. Now, okay?
Okay, sir.
Okay. On the left hand side and right hand side, reduce space. First, I draw a square like this. You must know how to draw the diodes in the correct orientation. Okay, draw a square like this. It can a bit bigger. Wait, why? Problem. Okay, coming. Okay, Arvind, are you in the group? Arvind Sivaguru.
Yes, sir. Yes, sir.
Okay. 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 So we draw a square. Okay, and then here we are going to draw 4 diodes to get full wave rectification. So we draw 4 circles over here. Okay, 4 circles. Okay, so now you're going to draw the 4 diodes so that you can get a full wave rectification. So how to identify? We got clue. Okay, very simple. There's once they asked this in SPM when we check the diagram. Confusing if you go through step by step, one by one, confusing. Very simple. You refer to this arrow like this from left to right. Okay, must be moving to the right like this, or from right to left. Either one only. Okay, either one. So you're going to draw 4 diodes. Okay, the first diode. First diode. Oh, sorry, this is not first diode. Okay, now I draw first. Second diode. Can see the arrow from the left to right. It's moving. So like this is the direction of the current flow. Actually, no, okay, we draw the diodes in the correct orientation, and then come to here. Also follow, but downward. Yeah. Okay. Finish. We try to cover as much as we can. The next week we finish up the story, then we discuss the questions. Then we start with the transistor. At least we can finish up until transistor is very good already. Yeah? Okay. Transistor, logic gate. Then we got another 5 subtopics only. Yeah, 5 subtopics. The important one. Okay. Now, finish. You see here the diodes here. From here going to the right. From here also going to the right. So going to the right, or you can reverse. From the right going to the left. Only these are the 2 possible connections that you can use. Okay, others cannot. Yeah. Okay. So these 2 terminals, we bring to the right. You want to connect to a transformer also can, like what I showed you earlier. So there you can get what? We can step down first, then we want to change the AC to DC. Okay, so here we give input. Okay, we write A, B. So 2 of the Terminals over here, we connect to the input. Here is the input. Anyhow, you see the diodes from the left going to right, or from the right going to left. These are the two possible connections that you can make. Okay. The next one is you want, okay, here you are going to connect to the output. Okay, here one more missing. You want to bring it down or you want to bring it upward also can. So now I want to bring it down. Okay, so here I draw like a bridge so that you can differentiate. It is not in contact. Yeah? Here is the load. Let's say it's a bulb or it can be anything, any loads. Okay, draw first. Okay, already draw. Okay, so on the right hand side over here, we can connect to a CRO. It won't disturb the circuit, CRO. Just want to display how the current that flow over here looks like. Okay. Then we come out with a few letters. Yeah, normally I use these letters. Okay, right over here, J, K, L, M, N, O, P, Q, R. Okay, you come out with these letters. Label first. Okay. Input we know already is like AC. Input is AC. Okay, we check. For first half cycle. Which one? Input. First half cycle. You want to write positive, second, but minimum first half cycle. Okay, second half cycle, third half cycle, and so on. Yeah. Okay, for the first half cycle, okay, let's say A become positive, B become negative. A become positive terminal, B become negative terminal. Okay, A become positive terminal and B become negative terminal. A become positive terminal, B become negative terminal. Okay, so remember, all of you listen. If the current start to flow from A, never mind. Whatever I can teach over here, next week straight I continue. Yeah, I think I need another 15 minutes to finish off. Okay, then you can start exercising. Okay, you want to try, you can also. Now, for the first half cycle, there is a positive half cycle, A positive, B negative. So if the current start from A, it only flow, okay, through the diode. Okay, it will flow through the diode and through the load, must complete at B. Then only can change. The current start from A, must flow through diode, must flow through the load, must come back to here. Cannot flow through the diode for second time. Then when the terminal change, current flow from B through the diode, through the load, then must end at B. Okay, so let's check. If the A positive, B negative, current flow, where is it? A, J, K. Where it will flow? Oh, I forgot to label. This one we label D1, D2, D3, D4. Diode 1, diode 2, diode 3, diode 4. Okay. So current flow J to K, through which diode is it? D4 or D1? Can the current flow through the D4? This way cannot, this way.
Cannot, sir.
Cannot. Whose name is L? Please rename. Who is that? L. Okay. Current flow J to K through the D1. D1. Because it's forward bias. This is reverse bias. D1 come to L, M. Then where's the current flow? Current flowing downward. This is what I. Current. Current flowing downward. Come to here. Go to P. Can flow not? Can. But the problem is earlier the current is going to flow through K to L. It is cannot flow again for second time. Something like this. Going on the same point, right? It's not complete over here. So current flow from A to J to K, L, M, N, P to Q, R to B. Okay? So current flow through diode D1 and D3. Okay? So we write over here current flow from A to J to K to L to N to N to O to P to Q to R, then complete at B. Current flow from A, J, K, L, M, N, O, P, Q, R, B. So at this moment, what happened? Current flow through diode D1 and D3 because these are the two diodes that allow the current to flow. So we say these two diodes are forward biased. Okay, so diodes forward biased. So D1 and D3. Yeah, diodes D1 and D3 are forward bias. Okay, diode D1 and D3 are forward bias. D2, D4 reverse bias. So diodes D2 and D4 are reverse bias. Okay, diodes D2, D4 are reverse biased. Okay, so okay, never mind. We'll go for the second one. Okay, so this one clear. Output I'll give you next year. Output I'll give you next week. I can draw this diagram very fast. Okay, so next week just continue only. Okay, now we come to for first negative arc cycle. Oh, sorry. For the first, not for second, sorry. For second arc cycle. Which one? Here. For second arc cycle, what happened? Terminals over here will change. A become negative, B become positive. Okay. So A become negative terminal, B become positive terminal. Yeah, A become negative terminal, B become positive terminal. Okay, now let's check current flow. Current flow through which part is it? A, B. Start from B to R to Q. Have a look over here. Later you can print screen this. B to R to Q. Here cannot, reverse bias. To D2, here also cannot. Must flow through the point M to N. You see? Still what? Same direction. One direction only. So this is what you call direct current. I mean, at the output, current flowing in one direction only. So current flow, B, R, Q, L, M, N, O, P, Q, R. Right? Wait, wrong. B, R, Q, L, M, N, O, P, D4, K, L, J, A. I will repeat this again next week, but a bit fast. Yeah? Okay? So, next step is current flow. B to R to Q to L to M to N to O to P to K to J to A. So the part. Okay, at this moment, what happened? Diodes current flow through D2 and D4. I will repeat, don't worry. Yeah? Okay, so diodes D2 and D4 are forward bias. Okay, diode D2 and D4 are forward bias. And then diodes D1 and D3 are reverse biased. Okay, D1, D3 are reverse biased. Okay, so you can print screen this. Next week, I repeat. Okay, we need to go through the output only with some additional information. Long time didn't ask question which involve the transform over here. Okay. So I have to stop over here because I got another class after this. So see you on next week. Please answer the polls here. Sorry, the Google form. Please reply. Okay. Thank you very much. See you next week.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.
Welcome.
Thank you, sir.
Thank you, sir.